Welcome to the Farm Bits Podcast, a product of Nebraska Extension Digital Agriculture. I'm Jackson Stansel.
And I'm Samantha Teton.
And we come to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews and panels with experts, producers, and innovators from all sectors of digital technology, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
To wrap up our series on quantifying and responding to soil spatial variability, we are joined by Dr. John Fulton, a professor in the Department of Food, Agricultural, and Biological Engineering at The Ohio State University. John's research and extension specialties are in digital agriculture, data analytics, machinery automation, and application equipment.
Our discussion today will center around how we go from maps to variable rate applications, and then how these applications are executed in the field using modern machinery technologies. Some aspects of this are considerations of the products applied, the algorithms used to go from measurements to target rates, and the accuracy of prescription execution with contemporary application technologies.
This episode will touch on elements of all the previous episodes in this series, so if you haven't had an opportunity to listen to those yet, I highly encourage you to do so.
So with that introduction out of the way, there is a lot to learn in this episode, so here we go with our interview featuring Dr. John Fulton. With that, thank you so much for joining us. We've been looking forward to this. So if you don't mind starting off by telling us a bit about yourself, your background, and how you ended up where you're at.
Yeah, well, both Jackson and Samantha, thanks for having me on. And it's always good to interact with the folks at Nebraska. I compliment what you guys do, and it's kind of a two-way street. We talk to a lot of folks out that way, and that's a good way of learning, but also challenging yourself to improve things. And you know, this is one thing is getting people together and talking about hot topics or important topics. So I appreciate the opportunity to be here. So, but a little bit about my background. Yeah, I grew up in a farm in Ohio, but more recently spent 10 and a half years at Auburn University. I know Mr. Jackson knows that well, and had an opportunity to spend a lot of time down in his neck of the woods and greatly enjoyed that experience. And then in, I guess, 2014, Ohio State gave me a really nice opportunity to come and not only to continue doing some of the research that interests me and the teaching interests me, but really building an extension outreach program here around precision ag. And ultimately today we speak a lot about digital ag to bring really the data piece and some of the automation pieces into that puzzle as well.
Very cool. So with that, speaking about your current research that you're working on, what are some of your current projects that you are working on, and some of the things that you're excited about in the precision ag and digital ag, I guess is the proper term, space right now?
Yeah. Well, just in terms of core research where graduate students been working here recently quite a bit on a sensor to measure granular fertilizer flow on equipment. And we may get into this in a little bit, but you know, when we think about planters and being row by row in terms of not only control but feedback, we'd like to maybe get ourselves more into a row by row, if not section by section. The real limitation there is the lack of sensor technology to be able to measure things like mass flow in a pneumatic airstream. And so I'm really excited about that. We've already kind of got down the road on that and kind of got through I guess not only justification but the ability to do that. It's really, you know, taking that to the next step and considering like commercialization. So row by row kind of granular fertilizer is something I'm really interested in because as we get into the discussion around variable rate, I think, you know, at some point in the future, we're going to probably have to have equipment to be able to measure and then control at that level, at that resolution. So that's one thing. A couple other things that we're working on and within the team, or my team is we're going back and doing some sensitivity analysis on mass flow sensors. And so when we think about conducted on-farm research, there's not a lot of best management practices published on the do's and don'ts as it relates to yield monitor data. And so if I'm working with growers, or just like you guys in Nebraska are, what sensitivity can we actually measure, and what kind of analysis, or how do we analyze that point by point data or groups of data in order to have confidence that, yes, that is my yield per unit area that we're trying to insert a treatment on. So we're doing some really cool stuff on that end to begin to understand sensitivity, but really to be able to write up at the end of this some of the real best management practices as we look at implementing on-farm field scale type research. So those will be two quick things that we're actively working on right now.
Sound like they're very, very applicable. We were just talking about yield data when we were coming up here to record, so it's about that time of year for it anyway.
Yep, I've been spending about 6 hours today working on one file and trying to scratch my head of why certain variables are such in a yield file, and I've yet to uncover those things. So,
might it be a case monitor?
A Pro 700?
No.
Oh.
No. This file was not generated off a case combine, but it's interesting, as you guys have probably, when you dive into this analysis, it's the data and trying to understand the data, just the integrity of it is challenging at times.
No question.
That's funny. Yeah, we're battling the same issues. So, okay, back to the topic at hand, though. So this episode with you is wrapping up our series on quantifying and responding to soil variability. So we've had the pleasure of talking about soil sampling, on-the-go soil mapping, and data processes that turn these measurements into maps. So now let's talk about how we're going to apply all of this. So the fertilizer side. What fertilizer applications should be informed by measurements of soil spatial variability, and why?
Well, I think as we stand today, for sure, phosphorus and potassium and micros are going to have to be connected to precision soil sampling. Okay, and whatever strategy or approach the grower decides, or the service provider offers to that grower. So that's for sure all connected up. I think the challenge is, and as we all know it is how do we deal with nitrogen in things like corn and wheat, in particular through the Midwest. And that's a little bit more challenging, and just because of the complexity of the nitrogen cycle and our ability to sense or identify what we think is profitable out there in the field and matching that all up. But from a precision soil sampling, no doubt, nutrients, macros and micros and lime is definitely, and I encourage growers, even small growers that haven't tried to do some kind of precision soil sampling, to pick a field or two and do that. I think there's a lot of things today that we've unraveled, or at least understood, that precision soil sampling followed by variable rate, there's an advantage there, not only profitably but from an environmental perspective too, when we think about phosphorus.
What exactly do you think some of those profit benefits might be? Can you kind of quantify the profit benefits and potential environmental benefits that you're maybe seeing in Ohio?
You bet. So what I'd tell you first, and then we'll come back and I tell you, our research would suggest on average, and again, this is a very broad average, that a grower is going to be able to save 7% on their fertilizer bill. And when I say fertilizer, we're talking about P and K. Lime is a separate piece in terms of that equation and profitability. That's no doubt. I think we've proved that variable rate lime is profitable, but from a fertility perspective, P and K, we can save on average 7%. Now, if a grower goes out and maybe hasn't precision sampled and all of a sudden finds what I describe as hot spots, that we have to have some corrective measures, that bill may go up first. But, over that, whatever your cycle is, 3 or 4 years, 2 years in your sampling cycle, in 6 to 10 years, basically you're going to get at a maintenance range. And when you're at that maintenance range, on average, you're going to be saving 7%. That may be more for some farmers, but I don't want to leave the conversation and saying, hey, right out of the gate, you're going to find savings, because there could be areas that you're just going to have to make some corrective measures and kind of throw the potash. In particular, what we find a lot of times, we're going to have to throw some potash out. That's really going to see some benefit on our soybean crops and the yields to soybeans. And then on the phosphorus side, just again, trying to get the maintenance levels across that field. On an environmental perspective, what I would tell you, Jackson, is you know, if we're matching soil needs and keeping ourselves below the critical level in a maintenance range, the opportunity for there to be offsite transport of phosphorus is going to be minimized when we're doing variable rate versus a fixed rate. Okay, because one, maybe a very simple example is if I'm doing fixed rate phosphorus and I continue to do that, and maybe there's some history of putting manure or some other, manure, or I may have some real high P test levels. And where a lot of times those are on the borders or on one side of the field, just again, because of history of what we've applied to a field. But it's in those, if I add a P, I'm going to have loss. The soil is like a sponge, right? If the sponge is full and I add another drop of water, that drop of water is either going to have to be absorbed and then put out the other side with that sponge, or it's going to just run off of the sponge. So with that in mind, it's kind of similar with phosphorus. I just think with matching your phosphorus and getting yourself into the maintenance range, the opportunities for loss in the system is much less, much greater, much less, however you want to put that, than just doing a fixed rate type approach across fields.
That's a good way to describe it. I think that's really easily tangible for people out there to understand.
I think it's great that you guys have taken the time to put some numbers to that profitability. Looking at the average across the state, that's really cool to see. Okay, so does the type of fertilizer being applied, so whether the grower can apply manure versus dry spreading urea or MAP, change whether the application should be spatially varied? So are some fertilizers better to spatially vary than others?
I don't know if I would say it's better necessarily, Samantha. What I would say is, in general, source doesn't matter as much when talking about inorganic. So whether I use urea or 28, and granted, as long as you have the units, they're there when the plant needs them. The source doesn't matter. Same for phosphorus and potassium. What I would say is that there are some nutrients probably easier to variable rate than others today. And probably my easiest example or simplest example would be manures are a little bit more challenging. Sure, we can do it, but it's a little bit more costly to implement and fully execute today. But when we look at 28%, we look at urea as an example as nitrogen sources. We look at MAP, at least here, that's our primary phosphorus source, dry. And we look at potash. Those are systems, and we have the equipment to be effectively to apply them out across crop fields. But manures, I would tell you, it's a little more challenging, especially on the liquid side and even on the dry side. It's more challenging to effectively deliver manures as we do some of these inorganic fertilizers.
What do you think is the biggest challenge or limitation for spatially varying manure? Is it trying to get a sense of what the actual nutrient content is within that manure? Is that one of the biggest challenges?
It can. We're doing a project right now where we're looking a little bit more into that, because we're working with a couple companies on NIR sensors for liquid manure. So we're thinking about dairy, swine, in particular here in Ohio. But as you unload the pit, we're not stirring our pits like we used to, but we're unloading them. There's potentially some concentration differences that occur over time. So to your point, normally we're going to take a sample out of the pit, analyze it, and say we're assuming that's what the concentration of the NPK is. But we know that as we empty some of these pits, there's going to be some variation as it empties. And so how do you account for that? Well, you're going to have to bring a sensor into the system, right? That's the only efficient and in my mind, the most efficient way to identify that and then make adjustments accordingly. So that's one thing, is to your point, is effectively over the entire application process, noting that. The other thing is again, if we're talking precision ag and we want to be as uniform as possible, take poultry litter, Jackson, just plenty of that back where
Yeah,
you're from, down home,
for sure.
trying to get that applied uniformly and effectively can be a challenge at times. And so again, it's a non-uniform application, not necessarily concentration, but delivering it, quote, in precision. We're already doing variable rate with it and not even put a variable rate controller on it. I mean,
Yeah,
that's the reality of it. So
yeah,
there's challenges with some of the manures. Do I think we'll get that addressed? Sure, in time, and being able to drive prices down for sensors, development of sensors, and those things, we'll be able to overcome some of those.
awesome.
Mhm. So I know there's lots of different methodologies behind it, but can you describe to us the process by which you would convert a soil property or a nutrient map and convert it to a spatially variable prescription application? How you would recommend that to farmers?
So I'm going to tell you two approaches that are. The first one is pretty common, and I think we all do it. And then the second one is really, when I think across the U.S., Midwest in particular, is becoming probably the I don't want to say norm, but highly adopted way of doing precision fertility management. So the first one, of course, is what we talked about. You either grid a zone sample, you send those to the lab, and then you use your university recommendations or what the university mentions as their recommendations to convert those soil sample results into an applied amount of whatever source that you've chosen to create those prescriptions. Most softwares, if not all precision ag softwares today, I don't want to say it's automated. Within 3 to 4 steps, you can go from sampling to having a prescription done on the field today. We've become, as an industry, much more efficient. Um, I don't know if people are interested. I'd tell you we're probably somewhere between 60 to 70% more efficient with time today. Going back, 15 years, there was a lot of steps. I mean, 8 to 20 steps to go from sampling or creating points to sampling the points or zones to sending that off, getting that data back. That was like depending on this program, a 12 to 20 step process. Today, most of the software packages that handle this in terms of not only creating points or zones and handling it, you can get down to 3 to 4 manual steps. So just think about the efficiencies that's brought to the industry in terms of just creating prescription maps for farmers today, and accuracy of that, in my opinion, too, because every time we automate, make sure that's accurate, we're taking an error source out of it. The second method today is in becoming fairly common across the Midwest. Farmers are generally sampling every other year or every 3 years, it seems like, in a lot of cases. Okay. In between, and so it's the same process, but it's becoming more of a check. Have I moved my soil fertility? And if I have, how much? And kind of learning from that. But we're also blending in those off years using yield maps for those cases where we're in a maintenance range of supplying back what we've taken off of that field, whether it's a 2 or 3 year rotation. So whatever I take off, in a lot of cases, we'll use a corn, soybean. What I took off with my corn, what I took off with my soybeans, from a P and K and micro perspective, my prescription map just gets converted basically as a yield map back to a removal map and ultimately a prescription map. So I don't know if that's answering the full question, but those have become the two common ways, kind of the basic and normal approach, and then this kind of modified approach where yield maps are becoming such a critical data layer to fill in those off years where we're not sampling.
Yeah, I think that answers the question. It's basically which algorithm do you want to use? Do you want to use the back calculations from the yield, or do you want to use those university recs based on the soil tests to get back to what you need to do?
Yeah, and it's both, right? We we don't want to over fertilize, but at the same time we want to use the university recommendations, because that's plays into this environmental piece too. Let's not forget that when groups look inside from the outside in, they want to see standards and they want to understand the standards. Of course, university recommendations become those standards. And so when we can state that, or a farmer states that, that's going to, in my opinion, will help out on that environmental discussion and the sustainability discussion at the same time, because you can point to, I am following those standards.
Would you like to put a plug in here for collecting good quality yield data to help with these recommendations?
Well, yield data is such the critical data layer, right? At the end of the day, I always talk about there's two primary data layers, and then we can talk about secondary letter, but yield year in and year out is one of those primary data layers that becomes so important if your farm is utilizing precision ag or precision ag services. And so if it is that important, being a good combine or harvester operator in conjunction with a technology operator becomes crucial to get quality data out. I can tell you today, I mean, we're moving slowly for improving yield monitors and the technology. For example, you look at area calculations, all the yield monitor based technologies. Companies that are building the base technologies for yield monitors have got this automatic area calculator now. It's like a coverage map. That's helped some. So when I'm operating point rows, or I forget to change my setting because I'm only doing a half header, we know that the area is at least a little bit better reflected than taking a full width or whatever we've got entered into the monitor. Calibration is always important. I know that's a tedious and cumbersome process. Deere's taken it to the next level and kind of have their automated process or calibration process. I would still encourage growers, even in that, to do some checks. It doesn't hurt, because I think my biggest challenge that I talk about with growers about this is we do a pretty good job at times calibrating, okay, but we don't calibrate out on the extremes effectively enough. And so Dr. Luck would be a good one to talk about this, that I don't care whose yield monitor you're using, those sensors are nonlinear. Those mass flow sensors are nonlinear in nature. And so if I don't effectively go to a low flow condition or down in those low flow conditions where it's 10 pounds per second, 15 pounds per second, 20 pounds per second, then I'm going to be in error when I hit those low yielding areas, depending on where that is in the field. And those errors can be 12 to 20+% in error. So if I'm a grower and I'm looking at trying to use the data layer to put into my fertility planning and rec process, then I need to know what those low yielding areas are to those high yielding areas as well, relatively, to be effective in using that yield data. So I don't know if I've got anything great other than calibrating and paying attention and doing some checks, especially as conditions. Moisture within the crops change, test weights change. You need to be checking your calibration. I always say at least 2 points on test weight. And so those are just general things to think about as you go through the season, of just doing some checks to make sure things are calibrated.
Seems like you and Dr. Luck are on the same page there, that's for sure.
We'll say we've had some discussions.
Yeah. So, we've talked about using these university algorithms to create nutrient prescriptions. We've talked about, basically using your yield maps to create these nutrient prescriptions. Are there any newer processes or algorithms that some of these private companies, like say a Climate Corporation or somebody like that, is using that may not match these university recs, or just accounting for our uptake of our previous crop, that are gaining some traction out there for growers?
Well, the obvious ones would be the nitrogen tools and there's 4 of them out there that are available. I'm not, I think there's some validity in those tools to help with nitrogen management. When we talk about site specific, meaning per field type analysis, it can be challenging. I think they can give you some suggestions and help you explain some things, but ultimately it's going to be yourself or the consultant tying rates to zones to make that happen on the nitrogen side. Though they've made a lot of progress. I don't want to discount those nitrogen tools. On the P&K side, I really haven't seen, other than maybe some new technology coming down the road, nothing today commercially that's really changed, dramatically changed what we're seeing from macros and micros in terms of how we manage and do that on a variable rate. We've automated or beginning to automate the sampling process out in the field. We're seeing that grow. But in terms of the algorithms, I think you're asking, Jackson,
Mm.
I I haven't seen a lot of movement on that part. One thing I would add to the discussion, or at least a thought around this discussion, is we're starting to see some companies get pretty significant volume of um, samples and information about fields built into their databases. So I know a few people are trying to begin to explore how to tap into that knowledge, those data, and maybe think about the P&K in particular and micros, but haven't seen any results here yet. That how do we take some of those pretty significant databases that have been built over the last 15 years, 10 to 15 years, and extract new knowledge about how we may or think about doing phosphorus and potassium.
That does make me think. I did see some research come out of Corteva, the people that have like put their soil samples into granular, and then they were just able to see across certain regions where there were lots of deficiencies. Like I said, I don't know how they're using that or what that's going to translate into, but it is fascinating to see those trends.
Yeah, yeah, and I think we're just starting to get to the cusp of that, Samantha, because we've got a couple companies here on the eastern side. Again, when you're able to connect yield fields with yield and some other descriptive layers, data layers, elevation, possibly, of course, soil type's always out there, but some other things that are very high resolution that gives us field by field. I think we can begin to explore some trends. We'll see where that takes us, but I would think here in the near future, we would start to see some of those trends and how we can translate that into a farmer using that for their recommendations or tailoring recommendations to their farm.
Just kind of building off of that a little bit into the manure side, since you did talk about a lot how manure is kind of its own challenge. Are there any like decision support tools or softwares that are helping producers stay in compliance with regulations or how to make prescriptions that fit their operation?
Mm. Well, I'm not sure I know anything that's new yet. I mean, for us, anyone handling manure, you have to have a nutrient management plan. So going through that process, doing a soil sample or some kind of soil sampling in conjunction with how did you arrive at those recommendations of how much to apply to a field, that's all done within a nutrient management plan and basically a certified operator that actually puts that typically out there. So that's somewhat what I want to say, overseen regulation process right now. So I haven't really seen anything new beyond that, at least back this way yet.
I think it's pretty much the same thing here. I think we were just kind of curious to see if there was any movement on that, especially as people are starting to think about potentially variable rating manure a little bit more and moving in that direction.
Well, if you want me to add just a few pieces to that. So in Europe, you're starting to see movement towards, I don't know if I'd say variable rate, but the ability to, back to our discussion, these NRR sensors have been developed and calibrated for manures in the European. Just recently in the last 2 years, you've seen companies bring them over here to North America. The thing that's going to take some time is because at least in my mind, primarily animal diets are a little different than what is in Europe, and that has a lot to do with what the constituents are or concentrations are in the manure. So we got to calibrate those to our manures. And so I think you're going to see a little bit of time and a little bit of diligence put into the calibration so they function or work accurately. And then once we get to that, what you're going to see, and we've already got this in our machines, right? I mean, with guidance packages today in machines, that manure sensor can be a feedback control loop back into the basically tractor. Typically we'll say pulling a injection bar or a tanker, and quite simply it's not controlling the rate on the applicator, it's controlling the speed of the tractor very quickly. And so what I can do is I can do my fixed rate a lot better knowing what I'm actually putting out. So I think we're going to see some of that as at least for us in liquid manures. I think that'll be one of the steps before we go fully variable rate. One of the challenges we have with variable rate is a lot of our liquid manures are put on with drag hoses. And so basically you got this big pump, you're pumping a large volume of material, and to vary the rate and make rate adjustments, what are you going to do with all that extra and all that pressure buildup in the system? And so there's some real challenges there, even on the engineering side, to get that effective. Now we can control the rate a little bit by tractor speed in our situation, as long as we don't overdo the tractor. But my point is we could be traveling 2 miles an hour up to 8 miles an hour and probably be doing that pretty effectively. And so we can variable rate that. But if we really want to do kind of what we're doing in some of the other inorganic fertilizers and have a broader range of rates that we want to control, then I think we got some engineering to do on the liquid side to effectively deal with some of the pressure and flows and the changes of flow in a pretty short period of time to make that work.
That's a very good description of exactly how much the engineering and agronomy need to match up. I mean, these engineered solutions, we may want to do all we want to on the agronomy side, but unless you have an engineered solution out there to do it effectively and at the I guess resolution that agronomists want it to happen, there are a lot of dots that have to be connected.
Yeah, and vice versa. The agronomists have to want to adopt it. So exactly. This is really getting off topic, but quick question. Don't go into it too much, but do you know what the level of adoption is of variable rate manure? Like, how many people have that?
It'd be pretty small. I don't know of a source or survey that has that, Samantha. I'm sure there'd be some out there, but it'd be really small. Mm-hmm. I mean, percentage point type, adoption.
Okay, awesome. Thanks. Yeah, we'll get back on topic here.
So when we're thinking about prescription still, how can we start using, or are people already doing this, using these precision technologies to execute on-farm research to then inform prescriptions on individual fields? What are some of the advantages and benefits that we may get out of that?
A really good question, and make sure you're leading me down the avenue you want me to go down here, Jackson. So my first comment is, if you got precision technologies on your farm, I would encourage grower to be doing some kind of on-farm research, answering their own questions. You guys have a great, on-farm research network out there. You're learning things not only for yourselves, but the grower that's cooperating, and there's just a lot of value. And when I think about prescription maps, there's two things, right? There's essentially, we'll generalize this. There's the zones. Are the zones right for the particular product that I'm trying to vary? That's your first question. And the second question is, how do I determine, in most cases, what rate or source that I'm going to put in that zone that's profitable? And so my thing is if you're not doing some on-farm research to evaluate your zones and then evaluate your rate or product or source that's going to go into that zone, I question how reflective agronomically those prescription maps are, and are they truly profitable for your operation? And I'm not sitting here pointing fingers and saying people are doing things wrong. There's a lot of room for all of us to improve. But for a grower, my question always is how do you know that's effectively providing a profit to you, and you've delineated the variability of whatever you're trying to vary out there appropriately. So, and I think you guys do a great job, and you can confirm with me, that's why we do a lot of this with our growers, strip trials, where we're not really varying whatever it is, the rate or source for the strip, but we're changing that between strips, and that gives us two ways. Number one, to evaluate our delineation of zones. Where should that be happening for that particular treatment? And then secondly, understanding within that zone, then we can go back and analyze and say, what was our optimum, or what was our economic optimum that should have been applied in that year? And if I replicate that over, I hate to say it, like 6 years, if you're in a soybean corn rotation, but if I can bear with the grower can bear with this, and we step through that all, I think they're going to be better off. And what they're going to find in the case of seeding, and maybe even some of this fertility at times, basically nitrogen, there's going to be some cases where, man, it's just a slam dunk. I should be doing it all the time in that field. To an adjacent field, I either need to learn more, or let's just stick with the fixed rate because it's profitable and it's easy for me to do in this field. But we find there's a lot of fields that are very tailored, or because of history, or because of the topography. A lot of times for us, it's drainage and topography. Right, it's elevation and drainage for us. If we can understand that, and then we can understand how we should be delineating and then adding, and what's our profitable either seeding rate or fertility rate that goes into that zone. So, but technology, precision ag technology, and easily enables on-farm research. And growers need to be profitable. And if they're having people make prescriptions, that's great. But they got to be evaluating some of this themselves. They should be asking their own questions on their farms and evaluating that, to be able to understand what is profitable, what practices work, what doesn't work, and be doing it out on a field by field basis, in my view. And if they can get to that, there's a real value and a real learning experience for them as they get into all this. I'll make a comment, and I can't remember if Dr. Luck was, I don't think he was involved with this project. We did a survey back in 2017. In fact, I think he was involved, and we surveyed only farmers that have been doing precision ag. So I'm talking about farmers that are all in on technology, they're real up, they're probably doing variable rate seeding and to some level on variable rate fertility. Do you know how many of them are doing on-farm research?
I don't even really want to take a guess, because I think I'm going to be wrong.
84% of the respondents are doing some kind of
Wow.
on-farm research. And I guess
Wow.
I use that as my testament that technology, I don't know if it simplifies on-farm research, but it really enables growers to go out and test some of their hypotheses or interests or questions very simply. And with that, it becomes that learning experience that they really want to understand, learn from and make changes or document, what, I am doing it right.
Yeah. I'd love to have our growers all line up a strip trial and give the UNO algorithm a test on their field and see if that's really coming out correct for them. I don't know if it's above, below. I've had conversation with the growers that thinks that the UNO algorithm way overestimates what they actually need to apply on their field. So,
all right, switching gears a little bit. We talk about spatial resolution quite a bit in digital agriculture. So with the current technology of variable rate, manure, and fertilizer, what is an appropriate spatial resolution to make prescription maps?
That's so we're talking phosphorus, potassium, micros and macros.
yep.
A lot of that's going to be dependent on what's available equipment wise. Okay. I'll tell you, modern equipment, modern application equipment, even a liquid applicator kind of behind me to dry fertilizers, or they can really make rate changes quickly, very rapidly. So when I think about the resolution of that, we could be down to a half acre, possibly a quarter acre, depending on the machines. And I'm talking about square in my mind, in terms of a quarter acre, half. If it's older machines, it's hard to really be much under 1 acre. So 208 feet by 208 feet. sometimes it just takes 2-3 seconds to make a rate change. And I guess I want to be able to effectively make that rate change and cover some area before it makes another change on that technology. But so my answer to that is a lot of it's dependent upon the equipment. But I will tell you, if you got new application equipment, you got new planters that have, if you're trying to do some things with starters or similar type products on the planter, those things can make rate changes pretty quick. I mean, within milliseconds in most cases.
Yeah, it's the machinery limitations are something that I think goes underestimated. In some cases, I know, with our active sensor research, the lag time is something that we think really impacts the efficacy of those sensors, because turning around a rate change, within a second is a really, really challenging thing to do when you're getting new sensor readings in every second. So
Absolutely. I mean, you're essentially chasing most days. You're chasing the rate change. That valve is, in my view.
yeah, that's kind of what we've seen. So,
Mm-hmm.
so in terms of, I guess, executing these applications, I kind of want to dig into kind of poultry litter and maybe manure a little bit more, and even thinking about not even spatially variable applications, but uniform applications. What are some of the primary equipment aspects that affect our distribution uniformity and our resolution the most? We've talked about valves here, but I think you did a little bit of work back at Auburn with a disc spinner for spreading poultry litter and trying to optimize that. So would you talk about that just a little bit?
Yeah, so we'll start with the valve. I mean, I'm kind of, I don't want to say I'm all in, but effectively to make rate changes quickly, you probably need to be using PWM type valves. Um, and the industry's kind of moved that way in general, regardless of the equipment and what you're trying to control. So that's one thing is I would encourage on poultry litter themselves. Jackson, what I'd tell you is that the bigger the discs, the more uniform you're going to be able to apply poultry litter. And it's been in 6 years now that I've been at Ohio State, and I have not been back and looked at any of the recent poultry litter applicators. But there was a day when there was a lot of 24, maybe 30-inch type disc, and I hope that they're all up to about 36-inch disc, if not bigger. But if they're all at 36, we'll take that. But having a bigger disc with a little bit bigger vein gives the ability, because of the nature of poultry litter, as you know, is highly variable physically, but that bigger disc and the proper veins, you're going to be able to throw that a lot more uniform than something small. And a lot of times if you're trying to variable rate, you can overwhelm a smaller disc at a higher, if you're trying to put, 2.5 to 4 tons out versus 1 ton. So that would be the big thing is if you're really truly going to variable rate poultry litter, in my view, then you need big discs, preferably 36-inch diameter disc on both sides, and then a fairly big or modern type vein that's big, and that'll really have a biggest impact over some of the older ones that have the smaller discs, smaller veins on them.
Sure.
So building on that, you kind of talked about where we are like at adoption and the technologies we do have. What machinery technologies do you think will be coming? What are people working on?
And in particular, maybe with those dry spreaders and some of the section control that you were talking about earlier.
Yeah. We're going back, let's switch back to the spinner spreaders that we've been using. We're starting to see quite a bit of technology come in play. Some of this has kind of been around, but I think just having access and manufacturers provide it is number one. Having dual or multiple bin dry fertilizer spreaders have been around for a while, but it's not until recent years that you could go to your retailer and actually look on the lot and actually see one on the lot. And so from a farmer perspective, what I like about that is I can put 2 prescriptions in, if not up to 4, depending on what you're trying to, you make one pass across the field. And so that's been a big area where today, think about planters. I mean, geez, we could put 8 prescriptions in if we're controlling hybrid, seeding rate, fertility, and insecticide per se. I mean, you could do that today. My point on fertilizer spreaders is we can very effectively today with the software, making the prescriptions and the applicators, do one pass, multiple products, executing individual prescriptions, because none of those prescriptions are all going to be equivalent spatial in terms of where the highs and the lows are. So I think that's been a real advantage and real development over the last five years to see that come into play first. Secondly, you're starting to see what I would call the European influence on spinner spreaders. And so when I say that is, number one, you're starting to see some new designs come into play that enable swath control, not full width swath control, but and a lot of times it could be 15, could be 12 sections, depending on the company. But they can actually effectively, with changing the position and the speed of the spinners on there, they can actually implement swath control like on your planter. So when I'm working in point rows or kind of abnormal shaped fields, it can shut off in sections and not just shutting off in like a 90-foot swath all at once and coming back on. It's actually broken down. Take your 90 and divide it by 12 or 15. It could be shut off and come back on in sections like that. And we're seeing that come in play here in the U.S. And so I'm starting to see that technology starting to be available or being on at retailers when you stop in and look around and see what they have for equipment. So that's another thing that's really come, is the improvement of section control and doing it by zones now on these fertilizer spreaders. I think that's a big advantage to not only them, but also the growers in terms of more uniform application of product.
I'm not super well versed in terms of how this equipment works, but how difficult is it to assess the accuracy and distribution of what's applied with these pieces of equipment? Because, as data analysts, people who are trying to figure out what goes on with yield, we kind of want to see that as applied. So how accurate is that right
now? For fertilizer, basically, you're getting a pretty coarse resolution as applied map. And so, again, going back to even the machine behind me, I mean, if you had a Raven, basically you're going to get full width, whether that's 90, 120, full width coverage map, and you're just kind of getting an average right across that whole boom. So we're getting pretty coarse on our as applied maps, if I understand where you're heading with that. And that where it comes back, there's a couple things. Number one, if we can get some sensors to put in place, especially on the granular side, to know exactly across the machine the uniformity, that's going to give us the granularity that I think you're looking for to be able to overlay with your yield map and other data layers spatially. And it won't be until we do that, in my opinion, that we can look at response curves in a lot of cases, because again, we can be off by 100 pounds sometime on a coverage map in an area. On average across the whole thing, it's okay. It's 200 pounds per acre, but in some cases I could be off quite a bit, 50 to 100 pounds in some conditions. And so I might be using 200 pounds of perceived applied product. In reality, I might only have 100. If it was some nitrogen or had some nitrogen in there, that's going to play a big significant treatment difference for you. So I think when we get some of these improved technologies that takes us to the next level for what I consider our as applied fertility maps, you're going to be able to do a much more improved analysis, both from the farmer perspective, but also for us that really interested in research. And with our ultimate goal is, can we ever get to a point of going suitably row by row or small area by small area to see some response and start to build those response curves that I think you were alluding to earlier, Samantha. We just can't do that today because of the I don't want to say inaccurate. It's just there's just not the resolution to do some of the analysis. I always frame up, and you guys are probably getting tired of me talk. I always talk about today, and I know you got some growers. I know some of the growers in Nebraska that have all the technology. If you're doing a high-speed planter, regardless if you're on a high speed or not, I would argue with you, you almost know where every seed was planted in the field. That's pretty high resolution, regardless if that's a 12 row, 24, 36 plus row planter.
Yeah.
But we don't have anything to be able to overlay across that relates to fertility to understand, well, I know what got planted. I can use a drone today to do my stand counts across that planter and know that, well, hey, I had maybe some issues, or I didn't get a good enough emergence in this area, but I don't have anything on the fertility side to add into that analysis at a fairly high scale or high resolution way. Does that make sense on that?
Yes, it does.
Yes.
Yeah, it'll be interesting how we're going to get to that point where we do have high resolution.
Yeah.
Um, so you mentioned earlier the 2 bins for dry fertilizer. So kind of speaking along those lines, are we going to get to the point where planters have 2 separate fertilizer products that can be applied at different rates for starter? Or we've talked about machines that have both anhydrous and liquid fertilizer and that they're applying at different rates. How are those being developed? Are we going to see more of that in the future?
Yeah, so so yes, from a planter perspective, you can put very simply a starter package on plus an in-furrow and put stuff in furrow, whether that's fertility to, if you want to do some of the other biologicals is another piece that people are really interested in on that. So being able to do multiple fertility products, multiple sources, for sure we can do that on planters today and do that pretty effectively. And I would state that if you want to spend the money, you could do that on a row by row basis very, very easily. But it's going to cost you money. That's probably the big hurdle on that front for that. On these other machines, whether it's dry or liquid and anhydrous or something like that, currently when we look at the if you want to call them strip till, we call them zone till type implements, where you're kind of doing a 8-foot or 8-inch by 3-inch depth kind of zone, and you're putting fertilizer in that in some fashion. Yes, you can do that and do different sources all in one pass, no doubt about it. And so I'm just thinking about 3 companies off the top of my head. They all have the capacity to run multiple sources on one implement and do that all in one pass. But I think that's where we're at in some cases, where research is going to have to determine the real value on some of that. For us, placing nutrients below the soil subsurfacely is an environmental value in our neck of the woods. Everyone says that if we get our nutrients, in particular nitrogen and phosphorus, in the soil, that greatly reduces the opportunity for that to leave the field. And so that's kind of BMP. Does that translate to profitability? I would argue yes, if it's done properly and we have some knowledge to supplement in there to understand how we need to be doing that. But maybe for others, it's more just to be able to kind of the right to farm, right? Environmentally, it's keeping people off my back, and I'm able to do what I want to do in some cases. So, but yes, we can do multiple products, multiple sources on liquid, anhydrous, and dry today. It's becoming, the technology's there, I guess I'm saying, and companies have the solutions.
That's good to hear. I actually am hoping that some of our growers next year for the sensor-based fertigation trials are going to have the ability to do variable rate fertilizer along with starter with their planters, because that would be the ideal scenario for putting some of these rate blocks in, I think, just to get it all in one pass.
Without influencing a bunch of other nutrients.
Exactly.
That's the big thing.
And that's the big thing. So we've been talking a lot about soil spatial variability and how that data might be useful for determining spatially variable applications. What are some other layers that you would like to see and you do like to see currently integrated with this soil spatial variability data to inform our spatially variable applications?
Well, if we're talking a little pie in the sky, I would love, industry is kind of driving some of this in terms of development. Boy, it'd be nice to have a couple things. Number one, the ability to, I guess we can measure some of this with sensors, but soil moisture variability across the field, being able to model that continuously over the growing season would be really, really cool data layer to play into some of this fertility management. I think in time, if we can get, maybe a couple more years of development work under our belts here, we may have some, fertility type sensors that we can stick in the ground and complement that as well. And, it's kind of like soil moisture sensing, how many do you need to stick out in the field? Well, probably going to be quite a few if you really want to do it right, just from a statistical standpoint. But if we get fertility at some level, let's say nitrate and aspiration, and even some kind of P level understanding, I will tell you, and soil moisture, boy, I'd love to be, if we could model those and be fairly confident over the growing season, I think that would really change our mind, coupled with weather and weather predictions, how we do fertility management more in season. I'll say it that way, from planning to in season type management.
So just to kind of piggyback on that, how would you like to inform where those sensors are placed in a field? I know you said there need to be a lot, but how, what would be your choice about how those locations would be informed?
Yeah, so we would, I think for us, we'd probably, and again, you guys have a lot different soil and topography and just your field conditions are different in Nebraska. So when I say this, I'm speaking, I want to make everyone understand I'm speaking in Ohio and what our conditions are. You guys need to kind of address what your major variables are. I want to tell you that organic matter and measuring that and having a high resolution organic matter map would be a big step for us. Next, I mentioned this before, drainage, and basically it's water holding capacity and drainage and coupled together, is if we can take elevation and build in a fairly high resolution where water flows, where it's going to stand in certain conditions, so elevation map and doing the derivatives of that and then doing our organic matter, we're going to have a lot of insight of where we need to place sensors across the field, because we're going to have highly eroded areas to essentially low organic matter potential, in those areas, to other areas that might be 3+% organic matter. So being able to use some of that information, and it's fairly readily available in Ohio, but that I think we could do a pretty effective job determining where we would place those sensors to inform some of if we're trying to model that or use that information to make decisions on. I think that would help us greatly. Those would be the data layers I'm thinking about. Of course, yield, love to put yield into that too, but every year's a little different in terms of weather patterns as well. So yield, we'd have to have quite a few years of yield data to put into that equation too. But those would probably be my three here in Ohio.
Cool.
Awesome. We have two questions to kind of wrap things up, but was there anything, we kind of skipped around a bit, was there anything that you want to talk about before we wrap things up?
Well,
we'll ask you like what piece of advice do you have and stuff, but I want to be sure we didn't miss any like major topics.
Well, I think is growers, farmers, and even us as research, I think we need to keep track of the equipment and processes that precision ag service providers are offering to us. I mean, it's one thing to be able to create a prescription map, and it's always I separate out to execute that's a different whole different component to the equation, right? I can create all kinds of maps, and I can even confirm that map's as good as it's going to be scientifically, but in terms of executing it and having the ability to do that is a whole different component of this. And so as growers, I just think you need to be thinking about both of those as two different pieces of your fertility management. And then thirdly, and come back to the on-farm, I still believe that on-farm experimentation really helps farmers fine-tune their fertility management. What practices, what rates, how are things profitable within my system? That's a necessity to keep at it. And the real advantage of that is the acceleration of learning that goes on with that farmer when they're doing that type of research.
So this episode will be released right at the end of the year in December. So what should farmers be thinking about right now? What would advice do you have to them for like planning out the next year?
Well, I'm going to say if your growers are like ours, they probably already got quite a bit of fertilizer purchased, and if not, quite a bit of their seed and seed packages that go on top of that purchased. But I think going into the first year, as it relates to fertility management, I think making sure you review your plan or plans if you're doing variable rate, making sure those are intact, they're sound agronomically as well. And I guess I would throw in that the challenge becomes is when can I execute those? And if I get a spring, a late winter and early spring that's pretty wet, all of a sudden, do I need to make adjustments to a plan in terms of what I'm going to actually apply when? And that's a big challenge. I mean, we've had to change some sources here in the last few years in Ohio. But my point in all that is as we go into January and February is, hey, I got a plan in play. I know what my costs are. Hopefully, they've know what your costs are, but have a plan B in mind, especially given if you guys are like us with some of these spring rains. If I've got to adjust things and maybe put a little bit more down on my planner, or I got to do a little bit more in-season application, I don't think there's anything wrong with that as long as it's done with the right source and the timing. But I think a plan A, what I'm going into the season thinking I want to do and have all that cost estimates laid out, but have a plan B back in my back pocket and be able to adjust given some of the spring conditions that we're encountering these days.
Perfect. I think that's probably what we want to wrap on right there. Is that's a good piece of advice for everybody out there who's listening. So.
Thank you to Dr. John Fulton for joining us today on the Farm Bits podcast. As you heard, he has expansive knowledge in fertilizer and manure application technology, and also how to utilize data layers for informed nutrient and line prescriptions.
I think my favorite parts of this episode were Dr. Fulton's discussion of some of the new variable rate application technologies, for example, on dry spreaders, and how we don't yet have a good way of measuring as applied rates at a high resolution. So we're thinking less than the 90-foot or 120-foot boom, especially with those machines. I also thought it was pretty cool to hear John say that we're at a point now where we could actually be applying 4 or more variable rate prescriptions at one time, particularly with the planter between variable rate seedings and nutrients and everything in between in response to that spatial variability out there in the field.
Absolutely. And for me, I liked his comments on how with many of these technologies, they show an obvious benefit to the environment, but we also have to find a way to show the value to a producer. And in many cases, such as in lime, phosphorus, and potassium, the return to the producer's bottom line is already there in most situations. I also liked his point about having a backup plan for fertilizer application timing, but then being sure to adjust your source to that timing to have the best outcome.
Absolutely. And having a plan B is never a bad idea. So that wraps up our soil spatial variability series. We'd like for you to tune in next week as we get started on another digital ag topic here on Farm Bits. Thank you for taking the time to join us today on the Farm Bits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can also be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of Farm Bits.